Hello and welcome back. Today is Math Course 1, Lesson 96. It's functions and graphing of functions as well. But let's just look at what we've got going on here. A function pairs one unknown with another unknown pair. So why would you need to know functions? Let me share this other screen here with you for a second. So if we know that a surface area of a rectangular prism, like let's say a number cube, dice, we know the surface area of a rectangular prism is the sum. That means you add up the areas of its sides. So if you know the area of one side, you know the area of all six sides. A rectangular prism is like a number cube, has six sides. So a cube is a special kind of rectangular prism with six square faces. And if we know the area of one of those sides, then we can find the surface area of that cube on all sides. Because all you need to do is take the area of the one side and multiply it times 6 so that you can find out the surface area of all six sides. We can make a table to show the surface area of cubes based on the area of one side of the cube. So here, if you have the area of one side of a cube being 4 centimeters squared, that means the surface area of the entire cube would be 24 square centimeters. Why? Because there's 6 sides. What's 6 times 4? 24. So when you look at that, you can see that using that information, you've got the data in the table helping you create a formula for the surface area of a cube. So let A be the area of each side of the cube, and S be the surface area of the cube. So you have S being the surface area of the cube that has 6 sides, A being the area of just one side. Your formula is an example of a function. A function is a rule for using one number, which is an input, or just any number, like we've got in this case 6, to calculate another number, an output. So in this function side area, side area is the input and the surface area is the output. Because the surface area of a cube depends on the area of each side, we say that the surface area of a cube is a function of the area of a side. If we know the area of one side of a cube, we can apply the function's rule or formula to find the surface area of that cube. So let's go back to this other screen here. So if you're looking at this, for example, you can see that this function has a rule. Or maybe you can't see it yet, but let me explain. In your position n, your first position, the term is 1. The second, n equaling 2, the term is 4. If you have n equaling 3, the term is 9. If you have n equaling 4, the term is 16. And what would be the answer to this blank if you're in the 5th position, or n equals 5? What do you suspect will be the term in this box? As you can see here, it was 1 times 1. Here it was 2 times 2, 3 times 3. If you were to multiply each of these by themselves, you see that it'll equal the term down below. This one was 4 times 4. This one is 5 times 5. So applying the rule of the function, you can find the missing number. So the rule of the function was multiply the number by itself. So we can predict what the 10th one would be. It'd be 10 times 10, or 10 squared, equaling 100. So we know that what this value would be is 25, and we know this value would be 36. And we can go on to infinity using that. So the generalized rule for this sequence is n times itself. So n squared. These all equal n squared. Let's look at an example here. Example 1, find the rule for this function, then use the rule to find the value of m when L is 7. So if L is 7, what is m going to be? Well, here I need to look at what my value is and what my output becomes. So what ends up happening here, how do I get to 20? How do I get to 25? It has to be the same rule for the function. So I have to be able to do the same equation, or basically do the same exact, am I going to add, subtract, multiply, divide? What do I have to do to 15 to get to 30? Well, whatever it is that I have to do to that has to be the same as what I would do to 5 to get to 20. So let's look at it. Let's try a couple things. If I was to just add, it looks like I could add 15. Can I add 15 to this and get 25? And can I add 15 to this and get 30? Yes, I can. Could I have multiplied this times 40 or 4 to get, no, to get 20? Well, I could have multiplied by 4 to get 20, but does it work here? Multiplied by 4? No, that equals 40. And if I multiplied this one by 4, that would actually end up being 60, so that won't work either. So because of that, you can't use 4. It might work here, but it has to also work down there, so we can't use 4. The only thing it looks like it's going to work, and it worked right away, our first attempt in our guess was add 15. So in this case, the rule is simply adding 15. So if I just add 15 to this, I know what m equals. M in this case will then equal 22. And you can see that function right here. So the answer to m equals L plus 15. And that's an L. Okay. Example 2. Here I have the function. They're giving us the function or the formula. So the function is 3 times x minus 2. Remember, you have to do please excuse my dear Aunt Sally. Please excuse my dear Aunt Sally. Forgot the D. Let me go back. My dear Aunt Sally Piedmas. Okay, and in this case, you need to look at what it would be if you were to plug in 2. You can see if you did 3 times 2, that's 6 minus 2 makes 4. If I plugged in the value of x, if the value of x was 3, that would be 3 times 3 minus 2. Well, that equals 9 minus 2, that equals 7. 7's the answer. So we need to do 3 times x minus 2, and then we need to plug in the value of 4 for x. 3 times 4 is 12, minus 2 makes this. So that would be 10. So in this case, the missing component is 10 using that rule right there. If we're graphing functions, for this one, you can see that the side is 1 and the perimeter is 4. Side equals 2, the perimeter is 8. Side equals 3, the perimeter is 12. So if the perimeter, or if the side of, the length of the side is 1, and the other one is 4, we would graph that. That looks like it'd be right here. See, this length of side is here, perimeter of a square is here. So I just put that in that position. 2 for the S, that's the length of the side. That'd be right here. And then 8 for the next one, you can see it would be right about here on this graph. And then 3 and 12 would be approximately right here. And 4 and 16 It'd be right about there. And you can see that they all connect. If we were to do that, you can see that nice little slope. If we were to continue this, I could go on to 5. But what would be 5? What would be the missing element here? What do you think? Well, if I did this, I see that I could take this times 4, and this one times 4, and this one times 4, and this one times 4. So my rule is always going to be P equals, it looks like S, actually it just equals 4S, right? I just want to do the 4 times S. So whatever S is, I'm going to multiply it times 4. You can see here. So 5 times 4 means that would be 20. And that would go on to infinity. I can continue to add those in. If I went to 6, I could jump down to 10. And what would 6 be? Well, 6 times 4 would be 24. And then if it was 10, the perimeter of that would actually be 40. 10 times 4. So I could go on to infinity just using that function. And this is a graph of the function. I have my length of side here, so this was the one thing here that I graphed, and then the perimeter, put it over here on the side. If I flip-flop those, it would still give you something similar result. Okay, here's another one. If it's 1 for the side and 3 for the perimeter, if it happened to be this, it looks like it's going up by what? This one looks like it goes up by 2. This one goes up by 4. This one goes up by 6. This goes up by 8. So that's kind of an interesting. That's a pretty interesting problem there, because it's not exactly uniform, right? It basically gives you a little different thing to work with. So, but when looking at that, you can see that the function of this, if you were to do your function, you can see that you're going to have 1 plus 2, this would be plus 4, this would be plus 6, this would be plus 8. That means the next one would be plus 10 if we went on, then it would be plus 12, and it would continue on in that same format. So if you were to plot those points, you can see that 1 would be here, and then 3 would be right about here. If we were at 0, it would actually be at 0 and 0, but it just had 1, 2. If we're at 2, it's going to be at 6. So that's approximately right here. See, this is 5, here's 6, and I have to line it up with that 2, 3, and then this 9, and then 4, and 12. Right? And there's my graph for that. All right, what's this one? If we've got this 5 converts into 20, 7 converts into 28, 10 converts into 40, what would be the function? Well, P equals something times S maybe. Would it be times 4? Let's see. Times 4, that works. Times 4. Looks like it's just times 4. So in this case, what's that going to be then? P equals 4S, same function we had prior to this. So if we add that, in this case we have P is going to equal 4 times 15. And in that case, this makes this 60. And if we're going to graph this, you know, you want to have 5, 10, 15, 20, 25. This would be 5, 10, 15, 20, 25. Now I have to go up to 60 in order to make the 15 there, but if I have my S's here and my perimeters here, and then this was 5 and 20, so this would be 5, 10, 15, 20. So here's the first one, and it would just keep going, carrying on. If this is 5, 7 would be approximately right here, and then 28 would be up here off the chart a little bit. Let's try these though. If you have a missing number y here, what is the value going to be for this missing y if x is 3, y equals 1? And if x equals 5, y equals 3, x equals 6, y equals 4, x equals 10, y equals what? What will be the missing value? I can see here that I'm actually, well, let me just use a red pen here because it's like I'm subtracting 2, subtracting 2, subtracting 2. I'm going to subtract 2 here. So that means the answer to this is going to be 8. I'm going to have 8 in this box. What about letter B? If you have A equals 3 and B is 8, if A is 5 and B is 10, if A is 7 and B is 12, what would be this missing value? All right, if you look at it, it looks like this is plus 5 works here, plus 5. You just try a few things, and if it works, it works. If it doesn't, it doesn't, I guess. So if this was plus 5, that means I'm going to subtract 5 from this, which makes this piece right here 10. What about letter C? If x is 3, and then you plug in that 3 into this function here, 3 times 3 plus 1 equals 10. If x is 6, you plug 6 into this, that'd be 3 times 6, which is 18, plus 1 makes 19. So what would be this last one? It should be 25, right? Because 3 times 8 is 24, plus 1 makes 25. What about this one here? You've got x equaling 3. If you have 3 times 3 minus 1, you get 8. If you have 3 times 4 minus 1, what is that going to be? As you can see, 3 times 7 was 21, minus 1 makes 20. So what would the value of this one be? 11. And in case you don't see that, it would be 3 times 4 minus 1. You got to do the multiplication first. That'd be 12, and then you just have to subtract it, and you're left with is 1. Okay. Now what about letter E here? The chemist mixed a solution that weighed 2 pounds per quart. Create a table of ordered pairs for this function for 1, 2, 3, and 4 quarts. Then graph the coordinates on a coordinate plane using the horizontal axis for quarts and the vertical axis for pounds. Let me just clear everything off here so we can use this space. I'm going to create my vertical axis right here. My vertical axis needs to be that way. This is a horizontal axis. It said the vertical axis needs to be pounds. So let me just write that here. And my horizontal axis needs to be quarts. Okay, so this is where what my graph will look like. If I'm going to do a function table, the function table is simply what you see here. So I'm going to just have, in this case, I have a Q and a P, and those are the two functions, two variables that I'm working with. And it says I need 1. So if I've got 1 quart, 2 quarts, 3 quarts, and 4 quarts, respectively, for those. And then it says it weighed 2 pounds per quart. So if we have 1 quart, that means it was 2 pounds. Okay, so if you have 1 quart, and let me just do that here. Here's 1, 2, 3, 4. We only have 4 quarts that we're dealing with. I know that I'm going to go by, it looks like I'm going to go by 2, 4, 6, 8, 10. I'm going to do that. 2, 4, 6, 8, 10. And these are all worth 1 each. 1, 2, 3, 4. So the first quart, here's where that would be. 1 quart equals 2 pounds. What would 2 quarts be? So what's the value of P? How many pounds is it? It's the same as if you take 1 quart times 2. So I'm going to just do this, 2Q. So that means I have to take 2 times Q, however many quarts I've got. So this would be 4 quarts, or sorry, 4 pounds for 2 quarts, which shows up on my tape graph like that. 3 times 2, that's simply 6, and that's going to be graphed here. Here's my 6, here's my 3. Need to make sure that they line up. And 4 times 2 makes 8. So 4 and 2 makes 8. Okay, there's my graph, and here's my function table. This is my formula or function that I needed to use in order to complete how many pounds each one of those things were, right? Because we didn't know how many pounds things were. We did know how many 1 pound or 1 quart weighed. It said 2 pounds per quart. So this is meaning just 1 quart. They basically gave us that information right there. Okay. All right, let's see how you guys can do on these 4 quiz questions here. You need to find the value of this box and this one. So you look at the term. If you have n, and then you have to figure out what the formula is that you're going to want to do for each thing and make sure it matches up. So if I'm going to add or subtract or multiply or divide, it has to apply to all of my answers here. So keep that in mind as you go through these. I'm thinking we'll probably count this as 1, 2, 3, 4, 5, 6, 7, 8 problems. It's actually going to be worth 40 points. So if you don't understand what's going on here, just ask, send me a message or ask before you go ahead and do all this. But just look at your term. This is your value and this is your output. If you have this value, you got to figure out what do you need to do to this 5 that was equally done to these n values to get to this term. Same with this, it's just they're talking about 1 chair has 4 legs. So how many does 4 chairs have? How many would 5 chairs have? 1 glove or 2 pairs of gloves, a pair of gloves, 1, 2 gloves has 10 fingers. Okay, so how many would 4 gloves have? How many fingers would 4 gloves have? How many fingers would 6 gloves have? How many fingers would 8 gloves have? How many fingers would 10 gloves have? Okay. Have a great day. Make sure you try to finish everything before midnight.